The numeric values used in this video are based on the optimum moisture content and maximum dry density previously determined for this specific soil and mold size. The results of the lime demand test, which determines the appropriate lime content for stabilization. For in situ soils, it is essential to first conduct compaction and lime demand testing. Water should then be added based on the difference between the existing moisture content and the target OMC. We begin with 513 grams of wet soil, prepared by thoroughly mixing 476 grams of oven-dried crushed clay soil with 37 milliliters of distilled water, 14.3 grams of lime, 1 milliliter of stabilizer, 0.5 milliliters of activator, an additional 37 milliliters of distilled water divided into 2 stages is used to reach the optimum moisture content. We will also require the following equipment: a large flat pan, a mixing bowl and a spatula for mixing soil, an electronic balance, a spray bottle for even application of solutions, appropriate volume cylinders and syringes, a compaction mold with a 55 mm diameter and at least 112 mm effective height. To prepare the sample, evenly spread the 513 grams of wet soil in a large flat mixing pan. Smear and break down large clumps, creating a uniform layer. Next, sprinkle 14.3 grams of lime evenly over the surface of the soil. Before use, shake the Chembase stabilizer thoroughly to ensure it is fully homogenized. Prepare the first solution by mixing 1 milliliter of Chembase stabilizer with approximately 26 milliliters of water. This represents 70% of the remaining 37 milliliters of water needed to reach the optimum moisture content. Evenly spray it over the lime-covered soil. Use the spatula to thoroughly mix the soil and incorporate the solution until it is evenly blended. Next, prepare the second solution by mixing 0.5 milliliters of Chembase activator with the remaining 11 milliliters of water. Spray this solution evenly onto the soil surface. Once again, mix thoroughly using the spatula. Then, using a rigid object such as a steel plate or flat trowel, press and drag the soil firmly across the pan. This technique improves homogeneity. Before compaction, apply lubrication such as Vaseline to the interior of the compaction mold to aid with sample extraction. Place a filter paper at the base of the mold. Fill the mold with the stabilized soil and gently tap the sides to help rearrange particles and minimize voids. After filling, place another filter paper on top of the soil. Transfer the mold to a hydraulic jack. Apply pressure until the soil is compacted to a height of 112 millimeters and maintain at that level for at least 10 seconds. Once compaction is complete, transfer the mold to a removal jack and extract the sample carefully. Seal the compacted sample with plastic wrap to retain moisture. Place the wrapped sample into an open plastic container and then place the container into a sealed curing barrel. Inside the barrel, place a separate small container filled with water to maintain humidity. Close the barrel lid to create a non-drying, humid curing environment. Allow the sample to cure for an additional 7 days. Once the 7-day curing period is complete, measure the weight of the sample with a pre-weighed container. The sample is ready for unconfined compressive strength testing.